All right, and now we're just going to take a minute to switch out the speakers, but I am very pleased to introduce Peter Wang, the CEO and co-founder of Anaconda.
All right, how's everyone doing? I want to give a big thank you to the conference organizers, to Emily, the chair, to everyone, all the volunteers who have worked so hard to bring us all together here. It is really wonderful to be in person with everyone again. I know everyone keeps saying that. I just want to reiterate how awesome it is to see everyone here. Actually, I can't see anyone because the lights are very bright, but I'm assuming everyone's out there. But today, I'm going to go through a bunch of different things. I'm going to talk really fast. I apologize. But there's a lot of ground to cover, and it's super exciting. Some new stuff we've been working on I want to tell you about. But the title of my talk is Programming for Everyone, or the next 100 million Pythonistas. You'll see why I call it that. But to get started, for those who don't know who I am or not familiar with Anaconda, I am the CEO and co-founder of Anaconda. And about 10 years ago, Travis Oliphant, the creator of NumPy and SciPy and my co-founder, we had this insight that Python's scientific tools, the ones that Sarah was just talking about, that the scientists have been nerding out on for over a decade at that point, that those tools were really ready for prime time in business data analysis and business data processing. At the time, it was big data and Hadoop and all these things, but we were a couple of weirdos at Strata conferences saying, use Python. And since that time, we've created a lot of things that now I hope are recognizable to many of you, open source tools, as well as really important things like the NumFocus nonprofit, the PyData conferences, a lot of different things like that. So that's where we started. And the reason why, I guess, one of the things that is really important to appreciate of why we did this is because there's a lot of things about Python that make it different and special, right? There's a lot that we love about Python, and hopefully this is not controversial to any of you. But I think there's a lot of other languages out there. If we just focus on software development, there's many different choices. Why was Travis and why were we so opinionated about taking Python to data science and to data analysis? And the reason is because of these things, right? It is something that is approachable by lots of people, more than just people with CS degrees. And this last part too, this last bullet point, the fact that the communities are welcoming and generally pretty pleasant, that's a really big deal. A really big deal if you want to keep growing the user base. There's one other thing that people don't talk about too much, which is the Python interpreter has essentially an under the hood capability to be extended with native extensions, as we call them, binary extensions. So I call it like a Honda Civic with mounting bolts for warp drive. And so it's very unassuming. It's a very common sort of thing. Kids learn how to do basic scripting with Python, and then you go into the trunk, you pop it open, and you bolt on warp nacelles, and now you're running faster than C or C++ in some cases, right? You're getting direct access to GPU. So this is one of those other things that is a little bit underappreciated. It's something that's obvious to me, because I've been doing this stuff for 20 years, but it's something I think really bears repeating. It's not just like every other language. It's not just like Node. It's not just an alternative to Ruby. The actual architecture of the CPython virtual machine itself has enabled, well, the kind of research you just saw, right? And research besides, on cancer research, on everything, right? Like, the reason why Python got picked up by Wall Street 10 years ago, 15 years ago, was precisely because of this warp drive capability. And that's what's led this incredible growth. If you look at these charts from Stack Overflow, from TOB, this year actually just hot off the press, TOB ranked Python as #1 again, continues to grow. We can continue to add users and popularity to the language. But all that being said, there's some things that are not so great, right? And so here among friends, I'm sure we can talk candidly about what sucks about Python. And I'll be the first to go out there and say that, packaging and installing all the bits, right? On the one hand, we have a diverse ecosystem of a huge number of libraries, over 100,000 on PyPI, I believe. But at the same time, getting all these to work together is difficult. And although there are many solutions, they all are about 80%, right? Which means everyone's having a bad time about 20% of the time, which is not great. Secondly, this is a really odd thing. For the world's most popular language, which we are, the challenge is we can't actually build things that have interfaces with. Like, you can't go and build an iOS app with Python very easily. Rolling a native application on Windows, which is what runs on most corporate desktops, trying to roll an application even with a web front end. You have to write JavaScript and CSS and HTML. So the fact that it's the world's most popular programming language, but we can't easily create things with user interfaces is kind of weird, but kind of interesting, right? And the consequence of 1 and 2, of course, makes it hard to share our work. And I know some of you are thinking in your mind, aha, but that's why I use Docker, right? And let's be clear, when you're using Docker, you are literally compressing, zipping up a hard drive and shipping it to someone. And that cannot be our way of getting this into kids' hands and getting people, millions of people to be using this stuff, right? There's got to be something easier. But again, despite all these challenges, Python continues to grow. Python continues to be the most popular language taught in schools at every level. And to some extent, I think Python is the victim of its own success. Precisely because it's so good at gluing together so many things, it's stuck to all those things it glues to, because it's glue, right? And so much of what we do in computing is tied to ideas, architectures, things that were built really in the 70s and maybe the 80s. And that is everything from the C programming language and the Unix process model and the compiler tool chains around all that, to concepts, like the common internetworking, TCP/IP, and all these other kinds of things. There's a lot of infrastructure that Python's able to kind of get into the nooks and crannies of, but then it itself gets dragged into. And so the thing is, the language proper, so if you read a Python tutorial, you can teach that to a child in an afternoon. You can teach that to anyone in a weekend. But if you really want to go beyond that, if you want to go from there to, like, let's say, shipping a native EXE on Windows or an iOS app on an iPad, that's a lot more work than an afternoon, right? And so the question I would pose is, can we unshackle Python from all of this, right? When you look at the Stack Overflow rankings of language popularity, JavaScript's right up there at the #1, and then there's HTML and CSS is #2. Python is right there, sitting comfortably on the podium at 3rd place. And can we ever get over that? Because the browser clearly has won the operating system wars, right? Is it the year, is 2022 the year of Linux on the desktop? I don't know, but I'll tell you 2022, there's a lot of web browsers on desktops, right? And the problem with the web browser, the reason why JavaScript is stuck there as king in #1 is because it's the native language of the web browser, right? And so if we want to grow beyond that, right, we have to go where the people are. We have to use dinglehoppers, or rather WebAssembly, to do this, because WebAssembly fundamentally changes the game. WebAssembly, for those who are not familiar, it is a virtual CPU instruction set that recently became a standard. It has a 32-bit memory space, but it supports 64-bit arithmetic. And there's a compiler tool called mscripten that operates as sort of a pseudo operating system layer. It compiles a lot of C and C++ code to target WebAssembly. And it's also WebAssembly, because it's a standard, it's well supported by most modern browsers, including mobile browsers. So for those of you keeping track at home, Python, CPython, is also a C program. A lot of the Python numerical stack is also written in C and C++. So the work that was done over the last couple of years by projects like PyData and JupyterLite, they've been compiling a large part of the Python data and scientific stack to target WebAssembly. And so if you go to pyodide.org, you'll get a nice little REPL, 3 little friendly angle brackets that you can import NumPy and Pandas into. If you go to JupyterLite, right, you can actually get a full JupyterLab environment, no server process at all. It just completely runs in your browser. And most recently, Christian Himes has been talking a lot about WebAssembly and doing some great work on this stuff. WebAssembly is going to be soon getting official CPython support as a Tier 2 supported platform. So again, it's a virtual CPU kind of instruction set, and it would be an alternative at an architecture level to things like the ARM instruction set or the x86 instruction set. It's just another kind of thing that the Python code base, the interpreter, can target. So we've been looking at this stuff for a little while, and at Anaconda, and we came up with an idea for how to really maybe leverage some of this work and increase the accessibility of tools like Python to many, many more people. And so I'm very, very excited to announce a project called PyScript. So what is PyScript? I'll show you what PyScript is. And I'm going to, yes, I realize I am live coding my first PyCon keynote here. Maybe my last. Everyone is like, what the hell? What's going on over here? All right, y'all ready for this? Whoa. Forgot what language I was in. Whew. And we're going to, because we're good citizens, we're going to close out that HTML tag right there. So that is an HTML file, and it is stored here. Where's my mouse? There it is. Here it is. If I double click that bad boy, there it is. Can you guys see that? It's HTML. Let's go have a little fun with it. Let's have a little fun with it. Let's put a blink tag in here. I save reload. No blink tag. See, I'm old school, right? I come from a time when there were blink tags, and now I have to explain to kids there's no more blink tag. So we're gonna have to do something a little different. We're gonna create a div out here. I'm gonna call it output. All right. In our Py script, we're gonna make our own blink tag. Y'all see where this is going? Hey, Vim, I love you. You gotta love you back. All right. Oh, this is not gonna work because code. All right, what do you guys think? What's gonna happen? What the W3C takes away, PyScript gives you back. All right? There we go. Nothing's going to stop us now. All right. So that's PyScript. So what's really going on here, right? When you look at something like this, it's very simple, right? It's about 10 lines of code. And we are just embedding HTML in the browser, right? It's a framework for creating rich Python apps in the browser. We interleave Python with HTML. We have full access to the DOM, and we can call and be called by JavaScript libraries. So all of your app logic, all your code is in one language in the browser. There's actually no web server needed. You saw that was just an HTML file that I double-clicked. I could put it on a USB stick and give it to somebody, and they could double-click it. Now, granted, you're like, okay, you have a script source equals. Yeah, there's a little bit something you got to do if you want to have the script locally, but the point is, all of the stuff is there in the HTML, okay? So this is how it actually works. It is not a variant of the Python language. I want to be very clear. This is the same CPython that all of y'all run on your laptops, on your servers. It's just been compiled to target the virtual CPU sitting inside the browser tab. And because of the PyData work from the PyData team, that project, we're able to leverage all of the NumPy and SciPy and a lot of the core data and scientific stack in Python. The PyScript infrastructure itself, it's kind of an opinionated framework with these tags and a way to do some FFI stuff, a way to kind of talk to the various bits and pieces. And the idea here is that Python, we have wrapped C, C++, we've swallowed them, right? We've swallowed C, C++, Fortran. We can also go and wrap and call JavaScript. Why not, right? So this is actually truly serverless computing. You can run client-side only. So let's look at a couple of additional demos. So here's the basic REPL. All right. 1 plus 3, print, hello. Well, you guys already saw this, but there's that, right? But you can also do, because it's just a DOM, well, and you got a little autocomplete thing there going on. This is the most number of people I've simultaneously rickrolled, so there we go, right? Yeah, get a little bit of that going on. Anyway, so that's your REPL, but this isn't Jupyter. I want to be very, very clear. What is this? Let's look at what this code for this looks like. Because this is a coding conference, so we're going to look at some code. Okay, there's some stuff here, but at the end of the day, you have just a little REPL. And we have this little PyREPL thing, and we have this auto-generate equals true. So PyREPL is one of the primitives that PyScript provides. Auto-generate means that every time you execute, it will create a new line for you. But you can also change where that output goes. So here, this is REPL2. There's a lot to kind of parse in here, but the key thing here is we are able to redirect standard output and standard error to different divs. So if I go here and I load up REPL2, I can do this, right? And this is not, just to be very clear, this is not Jupyter. Right? Many of you are familiar with Jupyter as the way of authoring and doing REPLs in the browser. This is just Python in the browser, PyScript, and then putting your output over here, right? So it's really nice. And you can, I won't Rickroll you again, but I assure you, you can get Rickrolled with this as well in the other div. No one needs to see that again twice in one day. Let's see here. The other thing I want to show is this little to-do app. And so, when you do web programming, the blog post, the to-do app, these are the kind of canonical examples, right? So eggs, we're going to add some things here. Add the task. Hold on, I know what's going on here. This is to-do.html. Let's do this guy. All right, so we give this a little second to load up the Python infrastructure. And then if we do eggs, bacon, ham, and you can do this sort of thing. I don't know if you can see it, but it's actually crossing out the item when it clicks on it. And the code for this, I will show you. The code for this looks oh, really? Oh, I'm in the wrong thing. Hold on. To-do.html. There it is. OK. So the to-do list app, most of the log, this is it right here. This is the HTML. It's about 50 lines. There's a lot of formatting and stuff, but ultimately what happens is we have a button here, this new task button, and when we click it, we call the add task function, which is actually defined in all of our actual Python logic. We put in a little helper file here just to keep it a little bit cleaner. OK, my vim is, yeah, there it is. OK, so your add task, what we're doing here is we're really playing with the DOM. We're able to pull things out. We're able to set the check mark on things. We're able to do all these kinds of things here. This is a really, the point here is that there's not a whole lot of translating back and forth to server state, to client state, and all these other things. You're literally just writing Python. You're able to import that Python code right into your page here, and you just kind of play with all of it, right? So it all sort of works. And that's nice. You're like, OK, these are some toy examples. That's kind of cool. See, showing what's going to happen. Let me just walk through these a little bit. So you can load the JavaScript and the CSS and all these things from a local server or a server you run, or you can run it off of PyScript.net. You can output to divs. You can do all sorts of fun things like this. The REPL can output to various different places, so you can build a nice little flexible set of REPL things. And you can do, actually, because this is loading all of Python in there, we're able to do more sophisticated examples, right? We're able to go and load, for instance, scikit-learn and the panel dashboard library with bokeh plotting and things like that. And so I'm able to sit here and actually do interactive scikit-learn in the browser with 0 install. So just to be very clear, this panel k-means.html, which is this guy. OK, again, there's a lot of stuff in the head which we'll clean up. This is all very alpha, so to be very clear. But we'll make a lot of this stuff get much simpler. But the core of the logic here is we have pyenv, where we oh, sorry, this is plotted with altair, I guess, and not bokeh. But we're declaring what we need in the environment to run. Those things get loaded up. And then the actual code here for this dashboard is all this Python, right? We're using Vega to declare the plots. And so you have interactive selection here, an update. All this stuff just runs client-side. And if I take this HTML file, again, similar to with the little REPL or any of those other examples, if I take this HTML file, I zip it up and give it to someone else, they can just run it. There's no install needed. So this is a really, really powerful example of how the distribution, the sharing, all those things that I said, what's Python not so great at, this, because it uses the browser as the primary interface and as the portable CPU, it just skips over a lot of those kinds of challenges. But you can do one step further. You can go and say, there's a lot of really great stuff in JavaScript. What if we could just leverage all of those libraries in JavaScript? DeckGL is a fantastic example of one of these powerful JavaScript visualization systems. And this example, again, uses the panel dashboard library, embeds a little visualization of the New York taxi cab data. We can animate it and see how, let's make the speed a little faster. So you can sort of see in these hex bins the number of taxi cab pickup and drop-offs there are on the Isle of Manhattan. But and you can modify this. So you can change the radius of how big the radius is as you're contemplating these or creating these bins. You can also change kind of visually. You can configure the thing. This is all pretty cool, right? You can slide this along. It's actually kind of neat. All this is running in the browser. No install. I could put this on a USB stick, give it to anyone here. You'd load up on your machine, and it would definitely work. Maybe, but pretty much. Look, I've been doing this a while. I know not to make sort of these absolutes, but the other thing you could do though, because this is actually running in the browser, and because you have a full Python environment here, you can actually just play with all of this, right? And notice how this changed this up there. Let's go back to 50, right? Also when you click on a thing, I don't know if you guys can see that, but it shows you where the taxi routes actually went to. Isn't that neat? It's actually a really beautiful viz. But you can also access the data frame of data itself. So the data frame, df, the format is a little tricky here, but it's 50,000 rows. But I can actually say, look, I just want to look at, let's say, the data frames where the trip distance was less than 5 miles. You guys see that? And it's interactive. So this is you can do more complex expressions. I want to find the big tippers. See what's going on here. There you go. Where'd the big tippers go? Right? So this is a really interesting capability where you have access to all of NumPy, SciPy, scikit-learn, like I showed you. All these things just sit here in the browser, and your distribution is, copying this on a flash drive, putting this on a file share. It's a dramatic simplification of what has been thus far a very difficult process, especially if you're building interactive web applications like this. So Gary Bernhardt, many years ago, gave a fantastic PyCon talk, not the what talk, actually, the birth and death of JavaScript, as he called it. And he talked about this possibility happening, ASM.js becoming WebAssembly, and we're just making it happen, right? This is what this is about. So I got some of these demos. Oh, another cool demo here is there's, because we can wrap JavaScript libraries, here's Folium, which is very nice. I'll let this load here. Yeah, I'm on conference Wi-Fi, so it's going to take a little bit. But, those of you, how many people here heard of D3? Know of D3? JavaScript Viz Library? A lot of Python data scientists have been lusting for D3 for a very long time. And many attempts have been made in Python to wrap D3. This is actually a Python wrapper of D3. The code looks like this. So part of this code shows you what the D3 code looks like. This is actually the D3 JavaScript code. For comparison, that makes the left side. The right side, this is the PyScript code. I mean, just look at this right here. Import D3. We can finally do that in Python now, right? And the cool thing about this wrapper for D3 was done by one of the team members in 2 days. Now, it's not complete, but it's a pretty good job. And so this shows the power of when we say Python wrapping things and calling things, Python's never been about re-implementing the world. It's always been about going where the things are, going where the users are, binding to them. So that's anyway, kind of cool there. And then there's also, of course, there's 3JS. So this is interactive WebGL. The logic for this is actually written in Python itself. Again, I forgot what it's called, though. Oh, yeah, here it is. So here you can see there's a little bit of preamble in the head to load some things and to style some things, but the actual logic from JavaScript import 3. We're actually using JavaScript to do the math, and here you're just doing raw WebGL in Python. This is the logic to generate the particles, all of the animation for this. It's not bad, right? But not only can we access JavaScript libraries, one of the really cool things we can do, oh, here's Folium, nice little Folium example. One of the really cool things we can do is also we can take different JavaScript libraries and bind them together. So Let's see if we actually make this work in a live demo environment. No pressure. Oh, it's got to load the model up over conference Wi-Fi. I'm going to keep blaming the conference Wi-Fi, although I appreciate the people who set up the Wi-Fi because it's very fast. Okay, here we go. Start the video. And when I move my hand, it's going to make Mario jump. And you're going to watch me die because there's a little bit of a lag. Oh! Woo! I can't jump very high, though. I'll always be little Mario. Can I do that? No. But the point is, this is tying together two different libraries. One of them is this JavaScript Mario clone. And well, don't go back on a demo. One of them is a JavaScript Super Mario implementation. The other one is it's a JavaScript-based gesture recognition library. And so the code for this looks like this. So this is not one of the trivial examples, okay, but using a mushroom fireflower.js, there's a lot to get loaded here. But if you look here, the Python is doing all the work of binding these things together. We're turning on the video. We're going to use hand track to start the video. When we go and we get the detection, we're going to go and look at the prediction. We're looking to see if the user's trying to move the thing left or right. If the hand is open or closed, then we make the jump, or, oh, I guess crouch is closed. But we're doing this in Python to bind these two JavaScript libraries together to do real-time camera video recognition to play a game. And I actually didn't get killed by the little Goomba. So like, this is actually really, really neat, right? I think it's pretty cool. To-do list app. So the recap, what have we seen here? We have Python and data science, MLAI running in the browser. We've got performant stuff, like we can harness the GPU. It's good enough to play Super Mario. That can keep me entertained for a number of hours, at least. There's zero install. It runs everywhere, right? I mean, I'm the Anaconda guy, and I'm telling you, you don't have to actually install Anaconda to use this. You basically get sort of a light Anaconda in WebAssembly to run all these things that you need. So the idea here is that the most accessible language for the web should be the language that we all already love and know. Let's make that happen, right? So that's PyScript. The other key thing about this, though, is if you think about traditional web applications, right, what makes them complex isn't just that JavaScript is kind of a terrible language. I'm willing to have beers with someone about that, but the point is, what makes really a lot of them complex is because we have this client-server architecture that splits the server state and half of the session state, puts it on the server, and the client is all the stuff written in JavaScript or TypeScript. And so it's a hodgepodge of different things. It's very complex, actually, much more complex than I think it needs to be. And the thing we don't talk about is the fact that because we split the session state in half, a tremendous amount of stuff goes back to the server that, like in the 1980s, 1990s, you wouldn't ever send back to a server. It'd be part of the object model state kind of living in the app itself. And this is the root of a lot of modern evils in tech. I think many people here who understand kind of how this stuff works know that's true. So if we do PyScript, we put all this power capability on the virtual CPU here in the browser tab, we can get rid of all of that stuff. Now, we will still need to we'll have to talk to databases. We'll need to have synchronization primitives. But if we use libp2p and we use things like Hyper or IPFS, right, we could really kind of maybe bring about a version of Web3 without the NFTs. We could actually do something where we're building applications that are properly client-server, right? And so what's next? Well, there's a lot of work. I mean, this is really, really cool stuff. I mean, some of the demos I think are pretty compelling. But there's a lot of really cool things that we can do, right? First of all, we got to wrap all of the cool JavaScript libraries and make them even cooler. Like there's a SimCity clone out there. There's DOSBox, like JS DOSBox, where you can go and reach into the DOS emulator for any of the games that the older people here grew up with. We can port other languages, right? We call it PyScript, but there's no reason you couldn't have the PyScript tag have a language equals and embed a bunch of Julia or R, or like the PyData tag having SQL in line with your Python. So there's a lot of really cool stuff that we want to do. We'd love to get other people to help us on the project and everyone's collaboration on this. There's a lot of really interesting problems, like what is the nicest native binding to React that we can do, right? What are some better ways to do efficient memory transfers back and forth between Python and JavaScript? All these different kinds of things, right? Better tooling for debugging in JIT and things like that. And there's a lot of hard problems too. Obviously, packaging is a hard problem. We're gonna have to sit down and really think about how we're gonna do this. in a way that lets people deliver secure web apps, but at the same time lets the community quickly iterate and move forward on things. We want to avoid any additional kinds of things that we've seen in the JavaScript ecosystem when there's lots of packages moving very quickly. So there's a lot to learn here and to think about. There's async and multi-threading things. There's a lot of potential here for beautiful, like really cool stuff with multiprocessing, sub-interpreters, and server-side stuff. But at the same time, it's like pretty subtle work. So we've got to make sure all this stuff works. And then we can actually build multiple interpreter backends, because many of the interpreters for Python, they can be targeted for WebAssembly, the alternative interpreters. And with all of the extension modules being targeted to WebAssembly now, all the other alternative interpreters to CPython can actually be on a level playing ground from a extension perspective, which has not been the case for a very long time. So the reason why everyone keeps using CPython, not because the CPython devs aren't cool, they're awesome, but the point is that there's a giant ecosystem of native libraries and extensions that only speak to CPython. So but now how do we do this without burning all the devs out? Because this is also a lot of really hard work. So as a community, we have to get together and really think about this and do this thoughtfully. But I think everyone recognizes there's a massive prize to be won here. It's absolutely massive. Ariel can get her legs. We can just go on land and go where the people are and solve the most fundamental and important problem, which is doing programming for the 99%. And what I mean by that is this. I think this is something that most people maybe don't think about. One of the things that I've known for a long time, but I think it bears repeating, is that Python has a unique position as a programming language because it was designed, has this design ethos from the founder of it, this creator, and all the core devs around it. There's this ethos about Python being approachable as a teaching language, as a language to learn, really, really prioritizing education in the community, things in the Zen of Python, like readability counts and explicit is better than implicit. Lots of these little things all come together to make it so that Python is a language that can be learned not just by the programmers who learn a new language every year, but by all of the other people in the world who don't consider themselves programmers, but they can do a little bit of something on their computer. And so this has led Python, this is one of the dynamics that's allowed Python to dominate the way it has over the last 10, 15 years. So how do we extend this, and how can PyScript help, right? One question I like to ask everyone, and just give you a moment to think about, how many software devs are there out there in the world, right? 100,000? Probably more than that. 100 million? Definitely not, right? How many are there? And when I did some research into this, the numbers all seem to converge somewhere around 25 million, maybe a little bit more than that, maybe a little bit less than that. But if you put that in perspective on how many people there are on the planet, it's 0.3%. So can we turn the house lights on here real quick? Is that, I don't know if that, let me do the PyScript, turn on house lights dot. No? Okay. There's a few, I asked a few people beforehand as my volunteers to stand up. Can my volunteers stand up? Who are my volunteers? All right. Oh, house lights, it worked. PyScript works, great. So, 6 people. If this room was the population of Earth, those 6 people are your software developers. Now, can 3 of you, this is a distributed computing problem, can 3 of you sit down? All right, there should be just 3 people standing. Okay, that's your Python programmers. Can one of you sit down and another person crouch? Okay, that's your number of people who know enough stats and whatnot to do some data science and ML. And then if we let the crouching person finally sit down and rest their legs, the one person standing, that is your AI ML engineer. All the rest of you have to use the systems that she builds, that she twiddles the knobs for. 0.3%, and actually less than that, 0.1% of the population has anything approaching the skills and capability to do machine learning, ML, AI. And you can turn the house lights off now, and thank you. You can sit down as well. The point of this is that this is not a good state of affairs. This is the state of affairs today, and it will continue to be the state of affairs unless we do something dramatically different. One of the things that I found very inspiring when I lived in Boston was the Boston Public Library had this huge engraving on the side. It says, "The Commonwealth requires the education of the people as a safeguard of order and liberty." So all of us here, well, many of us, most of us here are coders, and we like to code, we like to create things. Python is a wonderful language to help us do all those things. But we really have to ask ourselves, why do we code? What is it for? And I think it's really, really, really important that we keep our eye on the prize, which is that democratization and literacy, computational literacy as well as data literacy, are foundational to ensure an open and free future for humankind. So when we created SciPy and PyData, and we did all these things to try to spearhead the open data science movement, that was to ensure that machine learning and business computation in a cybernetic world had at least some open source and accessible foundations. With PyScript, I'm really hoping that we can broaden that mission to the broader web and to computing in general, right? Computing for the people and for their communities. So I would like to see kids' first introduction to programming to be PyScript. Install nothing. You have a tablet, you've got a little laptop, whatever it might be, you can go to the library computer and you're rocking and rolling, right? We don't have to reinvent anything because existing educational materials on HTML and CSS and Python, all these just pretty much will work. We can focus on productivity and quality of life issues for casual programmers, not the experienced software developers, because you all will happily take on a ton of pain, obviously. You will, if you bash your head into a wall enough, eventually the wall turns into a pile of YAML, right, which is a softer thing to bash your head into. And so the idea here is that I would love for us to make the web a friendly, hackable place where anyone can make interesting things and share it with other people. The remix aspect of this culture has really been lost, I think, in the last 20 years or so as the stacks have gotten more and more complicated. And so the idea here is to put joy back into all of it, really to promote creativity, for everyone to have fun, really want everyone to bring some crazy and quirky stuff into it. And by that, what I mean is something like this. You know, the old the XKCD thing that everyone saw, right? This is this comic where Randall Munroe was first getting introduced to Python. He just loved how it made him feel. Of course, later he had an XKCD where he made fun of the packaging mess that we had, so that was not so good. But you know, can everyone see that? Let's do that. Let's do more of that. All right, well, thank you all very much. I want to thank the people who made this possible. This project has been kind of crazy, but it's been a lot of fun. Fabio, where are you, Fabio? Stand up. I don't know where he is. He's right there. Fabio's the man. So tremendous amount of the work, all the credit, kudos to him. The Anaconda team making some of these demos, and my late night Slacks and everything, thank you all very much for being so responsive and making all this happen. The PyData maintainers, so Roman and Hood, have been amazing to work with. They've been so friendly. They have a talk on PyData and WebAssembly if you want to nerd out on the internals. They have a talk later this afternoon. Please go to that talk. And then Michael Dropboom and Christian Himes have been very supportive and very helpful with their feedback on all of this. The project is, again, I just want to reiterate, super, super, super alpha, right? In fact, when you put alpha in the URL for the JavaScript, you are signing the EULA to say you acknowledge this is alpha. But still, play with it, kind of like mess with it, figure stuff out. PyScript.net, come check out our open space that we'll have later today, or come by the Anaconda booth. Follow us, PyScript Dev, on Twitter. If you are the lurker, the squatter that has the PyScript Twitter tag, like, talk to me, I'll pay you money for it. And then also, please contribute and give us your thoughts on GitHub. So thank you all very, very much.